Hi everyone, and welcome to CS51's Introduction to Git. This video is going to explore briefly what Git is and how you can use it. Git is a piece of version control software. That means that it's a programming tool that you can use to keep track of changes that you make to your code, so that you know when you made changes and what changes you made. Version control also lets you synchronize code between different people, so that if you and a partner are both working on the same piece of code on separate computers, version control makes sure you're both up to date on each other's latest changes. Git also lets you test new changes to code without losing the original copy of it, and lets you go backwards in time to previous versions of your code if you want some of your old code back, for example. So that's a quick summary of what Git can do for you. Now let's take a look at how we would actually go about using it. Git mostly operates via the command line, and one of the first commands you'll likely need to know is called git clone. Git clone takes the contents of a Git repository, which is just a directory or folder containing files that you want tracked by Git, and makes a copy of it on your local computer. So if there's a Git repository living somewhere on the internet, we can use git clone, followed by the URL of the Git repository, to get a copy of it on our machine. Let's try an example. I'm currently looking at a Git repository on Bitbucket, a website which stores repositories online. This repository contains just one file, called functions.ml. I can clone the repository by copying the link to the repository from the clone button and pasting it into my command line. Once it's downloaded, I can enter the repository like I would any other folder on my computer, and then I can see the files inside. Now let's talk about git add. After we make changes to a file, we can use git add to tell Git that we want to include the changes made to this file the next time that we save a change to the repository. So if I add a line to my file, and want Git to include that change in the next revision of this repository, I can just say git add functions.ml. Once I've added a file to the so-called staging area, I can now tell Git that I'm ready to save a new revision. Git calls each revision to the repository a commit. When I make a new commit, Git saves the changes I made in this commit along with the commit message, which just briefly describes the changes I'm making to the file. But it also preserves all of the previous commits in case I ever need to go back to them. So I can type git commit -m followed by my commit message, and that will create a new commit to this repository. Git status can often be a helpful command just to see what's currently going on in your Git repository. You can always type git status to see information about the repository, such as what files you've changed, and whether you're ahead of origin, which is the online version of your repository. Right now, if I type git status, I see that I'm ahead of origin by one commit, because I've saved one revision of my repository that hasn't yet been reflected online on Bitbucket. So how do I get my local changes on my computer to update the online origin version of the repository? That's where git push comes in. Typing git push after you've made commits will push those new commits online, so that if you have a remote version of your repository on a server like Bitbucket's, your new commits will be reflected there. Indeed, if I try typing git push and then check Bitbucket, I'll see that the changes that I made are now there. So what if, on the other hand, the repository online is more up to date than my version on my computer, and I want to download the most recent commits? Git pull does just that, by downloading and applying any new commits from online so that my repository on my computer is up to date. If I check Bitbucket now, for example, I see that there's a new commit that doesn't exist on my local version of the repository. So I can go into my terminal, type git pull, and then the new commit from online will be downloaded onto my computer so that I have the latest version of the code. Now consider this situation. I've made changes to a file on my computer, and someone else has made changes to the same line of the same file on their version of the repository on their computer, and they've pushed it to Bitbucket. Now, when I try to git pull, the two versions conflict with each other. This is called a merge conflict. When a merge conflict happens, we'll be notified that we need to resolve the conflict. To resolve a merge conflict, open up the file which has the conflict, and you'll notice that Git has automatically inserted some conflict markers in the code. Everything between the less than symbols followed by the word head and the line of just equal signs is our version of the conflicting code. And everything after the line of equal signs and above the line of greater than signs followed by a sequence of seemingly random numbers and letters is the version that we're trying to merge with that's causing problems. It's our job to pick which version of the code we want, or maybe edit it to be a combination of both, and then get rid of the lines we don't want, along with deleting those conflict markers. Then we can commit our changes as a resolution to this merge conflict, and use git push to send our changes online. Let's look at an actionable example. Say I change a line of the code in my file, functions.ml, and then I commit those changes. If someone else has committed a change to the same line and pushed it online, when I try to git pull, there's going to be a merge conflict. The message says there's a merge conflict in functions.ml. So if I open up functions.ml, I'll see the conflict. Notice the conflict markers. Everything in the top half of the conflict area is my version of the code. Everything in the bottom half is the conflicting version. And that sequence of random numbers just identifies which commit I'm conflicting with. To resolve the merge conflict, I just need to get rid of the conflict markers and get rid of the version of the code I don't want. Then I can commit my changes and push them. And now I've resolved the merge conflict. Once you've started making more commits, git log is a helpful tool which lists a history of all the commits made in your repository. For each one, you can see who made the commit, when it was made, what the commit message was, as well as the commit hash, that sequence of characters that identifies a commit. With that information, we can now git reset to revert the state of our repository back to some previous version in history. By typing git reset --hard plus the commit hash of the commit we want to go back to, we can reset our repository to a previous state. Now note that usually we don't need to include the whole commit hash to do this, just enough characters to uniquely identify it. I can type git reset --hard followed by a few characters of the commit hash, and now my repository has gone back to an older version. If I want to reset my repository back to be in sync with the most recent online commit, I can type git reset --hard origin/master, and that will bring my repository back to the most recent commit on my online or remote origin repository. Finally, let's talk about branching. Branching lets you maintain different versions of your repository at the same time. Each branch has its own commit history and its own most recent version. By default, all of the work you do on a repository is on the master branch. If I want to make some edits without fear that I'll mess up master, I can create a new branch via git branch followed by the name of the branch. Typing git branch alone shows me all of my current branches. Right now, it's just master. So if I want to add a new function to my code here, but I don't want to mess up master, I can create a new branch called sumFunction via git branch sumFunction. Now, you see I have two branches, master and sumFunction. I can switch to a branch using git checkout, followed by the branch name. Let's switch to the sumFunction branch. I'll edit the file on this sumFunction branch. Note that now, when I add it to the staging area and commit my changes, this commit will only exist on the sumFunction branch, at least for the time being. You can see it here. But if I switch to the master branch, as via git checkout master, you'll notice that the master branch version of the code is different and doesn't contain the new function. Once a branch is done and I'm ready to incorporate it back into the master branch, I can use git merge to combine commits from two different branches. If I'm on a branch and I want to merge some other branch into this branch, I can use git merge followed by the other branch's name, and that will merge the other branch into the one I'm currently on. So if I'm on the master branch with the old version of the file, I can git merge sumFunction to merge the sumFunction branch into the master branch. Now, the commit I made in the sumFunction branch to add the new function is reflected in the master branch. And I can see that I'm definitely on the master branch by typing git branch again. So in summary, Git is a version control tool that lets you keep track of changes to your code, synchronize code between different people, test changes to code, and revert code back to previous versions. It works with online sites like Bitbucket and GitHub to let multiple people work together on the same repository. Git is an extremely powerful and useful tool in CS51 and in computer science more generally, and hopefully you feel a little more familiar with how it works now. As always, feel free to reach out to any of the course's staff if you have any questions. We're here to help. Thanks for watching.